In the last class, we discussed about KCL and KVL, how to define KVL and how to do KCL, and so many terms related to circuit. What is branch, what is loop, what is mesh. And now we go for how to solve numerical problems on KCL and KVL. Okay, there are so many methods to solve the two equations, because in KVL or KCL we are obtaining so many equations. One or two or three equations we are obtaining. Three equations how to solve. We know simple method, by cancelling the terms we can solve the equations, two equations. Suppose 2x plus 3y equal to 10. Next 2x plus 6y equal to 7. Then by making difference, then cancel each other. Then we can solve. We can get y. After the y equal to 3y plus 6y minus 3y equal to 3 y equal to minus 1. Like that we can solve. If you substitute y in this equation, then we will get x and y both. Not only those, if there are two unknowns are there, x and y are unknowns, where 10 and 3 are constants. These are the coefficients of x, coefficient of y is 3. Okay. Now if the equation is like this, suppose the equation is a1x plus b1y equal to c1. If the equation, another equation is a2x plus b2y equal to c2. Like that if the equation is, then we can solve by using Cramer's method. It is very simple method in the form of matrix if you convert to unknowns. Let us go for solving the equations by two unknowns. Make it in solving equations by two unknowns. Solving the equations by two unknowns and three unknowns, how to solve. It is very simple to solve two equations, but three equations means it takes time. But by taking matrix and determinant form and Cramer's method, that can be useful for a very simple method to solve the two equations. Okay. Make it in solving equations by unknowns, two unknowns. Suppose if two unknowns are x and y are two unknowns, then how to solve? We can convert this equation into matrix form. A1, A2, B1, B2. It is into x and y. That equal to constant C1, C2. This is the matrix form conversion. Okay, matrix form conversion. A1, A2, B1, B2 is one matrix that is multiplied with x, y, and these are the constants C1, C2. Then we are calculating first determinant of this common matrix. Delta equal to A1, B2 minus A2, B1. That is delta. Now if you want to calculate x, then we are replacing this where x coefficients are A1, A2. We are replacing this A1, A2 with C1, C2. C1, C2 we can replace. To calculate x, that is known as delta 1. Determinant 1 we are calculating first. Determinant 1 or delta 1 equal to, now we are substituting in place of that C1, C2, B1, B2. Now finding the determinant for this. Delta 1 is the determinant for one matrix. To find x and y, where x is the coefficient of A1, A2. In this place we are substituting C1, C2. Then determinant 1 equal to C1, B2 minus B1, C2. Okay. Now to find y, what we are doing? To find y, C1, C2 are replaced with B1, B2. Now the matrix will be A1, A2, C1, C2. That equal to determinant we are calculating again A1 minus A2, C1. Now it is the Cramer's method to find unknowns x and y. Now to calculate x, delta 1 by delta, determinant 1 by common determinant. It is the common determinant. It is the common determinant. Okay. It is a simple method how to solve the equation x, how to find unknown x, delta 1 by delta, to find y, delta 2 by delta. Then we can substitute delta 1 is C1 B2 minus C1 C2 divided by delta. A1 minus Similarly, we can calculate y. Okay. If the two equations are very simple, we can do directly. But if it is a difficult, we can convert into matrix form and simply by doing Cramer's rule. Okay. This is the method. Delta 2 and delta, if you substitute, then you can get directly x and y values. No need to cancel the terms and do the calculation. By converting the equations into matrix form, we can do it. This is the method of finding two unknowns. Suppose three unknowns are there. Three unknowns, then three unknowns are there in the equation. You can write this one. While running class, you have to write running notes. This is the method of finding two unknowns. Okay. Now two unknowns are x, y. Z is there, assume that C1 Z plus C2 Z and A3x plus B2y plus C3z equal to D1, D2, D3. Now there are three unknowns. X, Y, Z are the unknowns. Now we are replacing with 3 into 3, 3 by 3 matrix. 3 by 3 matrix is A1, A2, A3, B1, B2, B3, C1, C2, C3. Yes, D1, D1, D2, D3.